Hello, everybody, and welcome to my class. Today, we will be talking about inequalities. Okay, this is the seventh grade curriculum, and this will be our second class on inequalities. So, let me go over our schedule. Our schedule. First, we're going to have a review of last class. Basic inequalities, the single variable inequalities. Shouldn't be too hard. I'll also go over the graphing of some inequalities and that involves slope-intercept form. So I hope you have a basic understanding of that. If not, I'll review it as well. And then we'll be introducing compound inequalities and then absolute inequalities. Now, I trust that you probably have a easy time understanding compound inequalities, but absolute inequalities, absolute value inequalities are a bit confusing. So if you have any questions during that teaching session, then I'll happily answer them. So, are there any questions about the schedule so far? No questions? Then I will continue. So, first we're going to go with a little review. Okay, so how to solve and graph inequalities. Okay, so let's take a very simple inequality. So I like all the participants to participate in this warm-up question. So please come up with a very simple inequality. I'm sure you can all do it. An inequality is basically like an algebraic equation, but with an inequality sign. Okay, can anybody come up with an inequality? Okay, Frank says x is less than 3. Very good. That's a very simple inequality. And that already gives you what x is. What x is, right? X is x is less than 3. Okay. You already know what x is. Okay, so actually I'm not going to use the example here because I'm going to teach you how to actually solve them. Okay, but this is a very good example of what your solution should be like. The variable should be on one side while all the numerals should be on the other side. Okay, so let's come up with one. 2x plus 1 equals x, okay? Something like that. And this not equal sign. Okay, I make that mistake quite often. So this is an inequality. No equal signs. Inequality, okay? Not going to be equal. Let's say 2x plus 1 is greater than x. Okay, and while I'm at it, I'll review all the inequality signs. First is less than and greater than. I'm sure you all know. But then there's less than and equal to, which means, let's say x is less than or equal to 3. X can be equal to 3 as well as less than. But if it's just less than, then x cannot be 3. It can be 2.9. That is not 3. It just has to be less than 3. Okay, and then vice versa, there's greater than and equal to. Okay, so we have our very simple inequality here. 2x plus 1 is greater than x. Okay, so let's solve this one. Remember, we have to isolate the x on one side and all the numerals on the other side. Okay, if you have a basic understanding of algebra, you should know this when solving. Okay, we move it to the side and remember to include inverse operations. Okay, this is a positive x right here, but when you move it to the other side, you basically just subtract x from the side, subtract x from both sides, basically just move it over and switch the sign. So then you get x plus 1 is greater than 0. And then move the 1 right here and also include, also use inverse operations here. So x is greater than -1. Now, I'm also going to introduce or review a concept of inequalities right here. So let's say negative -1/2 x. Okay, so -1/2 x is less than 1. Okay, let's just say that. Okay, and as you know, if this were just an algebraic equation, then we would just divide both sides by -2 to get x by itself, right? But when we're solving inequalities, okay, so we divide by -2, x is less than 1/1/2, right? But that is not true when we're solving inequalities. There's a special rule when we're solving inequalities, and that is when you divide by a negative, you have to switch the sign. If it's a less than sign, switch it to its opposite, the greater than sign. So the actual answer for this would be x is greater than -1. Okay, so now I am going to graph these inequalities. Okay, so if we only have one variable, it'll only include the x-axis. We only have the variable x, so only the x-axis, so one axis if we have one variable. So let's graph this one. Okay, let's graph this one. X is greater than -1. Okay, so this is 0, and -1 should be around here. Okay, -1, let's say, is right there. And let's graph it like this. Okay, that should be our graph. Now, why? Because x is right here, right? X, this is -1, but x has to be greater than -1. So all the numerals, real numbers that are greater than -1, right? Go to the right side here, are all solutions to this inequality. Now, when we're graphing, we have to pay attention to what kind of circle we're working with, okay? So right here, I graphed an open circle. And an open circle is when you have a less than or greater than, okay? No equal to. So just a plain less than or equal or greater than, okay? But when you have greater than or equal to, you have to fill in that circle, okay? Then it'll be a closed circle. And that is how you graph a single variable inequality. And later, I'll also introduce or review how to graph two variable inequalities. So, any questions so far? So okay, grades is good. So oh, Carney, you asked what does the n equal sign do? The n equal sign is just the n equal sign is like this, right? It's just not equal. It's not specifying what it is. Okay, so 3 is n equal to 4. That's facts, right? You can have x is unequal to 4. Now that doesn't specify how it is unequal to 4. Okay, x is either then less than or greater than or less than or equal to or greater than or equal to. So basically this unequal sign is just very broad, okay? It doesn't specify how it is unequal. So without further ado, let's solve this first problem. So please solve and graph this inequality. 2x minus 3 is greater than 7, okay? So after you solve it, remember I taught you how to graph it. And I'll give you a hint. This is a greater than. So it will be a open circle. Okay, an open circle. Okay, Frank says x is greater than 5. That was very quick. Let's see. Very nice. X is greater than 5. So, let me walk you through this one. 2x minus 3 is greater than 7. Move the negative 3 to this side. 2x is greater than 10. And remember, divide by 2. And this time you don't switch the sign, okay? You don't. Why? Because we're not dividing by a negative. Only when you divide by a negative, you switch the sign. So here we have just x is greater than 5. So very, very nice job, Frank and Jason as well. Okay. So let's move on to the next one. This is a bit more complicated. This one has a set of parentheses in it, and you can use the distributive property to solve this one. Okay? So, please solve this one for me, and also graph it. Just graph it on your paper. I forgot to graph this first one, but I'll graph this one. Okay, I'll graph this one for you. So I'll give you a few moments to try and solve this inequality. Okay. And it seems Jason is the first one. Okay. And Gemna asks me, can I go slower? Okay. Very well. I will go slower. Okay. But if you have any questions, overall, like when I'm teaching, please put them in the chat. I'll check it. I'll try to check it regularly to look for any questions. And Reza also asked me, does the x stay on the left or the right? Okay, so this is a very good question. Let's say x is less than 3, okay? It can be on the left-hand side, and it is traditional, the standard way to put it on the left-hand side. Usually all those worksheet problems, they're all on the left-hand side, but you can put it on the right-hand side. It's the same, right? It's the same. But you just have to change the sign over. Okay, if x is less than 3, then 3 must be greater than x. Remember, when you flip it over, you have to change the sign as well. So, I think we got a lot of answers here. A lot of you got x is less than or equal to 7/4. Okay, very good. Very fast answers, and that's what I like. Okay, so 3 times 2x minus 2, that's our distributive property. 6x minus 6, right? So 3 times 2x minus 3 times 2 is less than or equal to 2x plus 1. Okay, so that's our first stage. We simplified it. Next, let's move these terms. Okay, so 2x to this side and negative 6 to the other side with a 1, and we should get 4x is less than or equal to 7. So then we divide both sides by 4. X is less than or equal to 7/4. And everybody got that. Okay, very good. Okay, so Gemini, what should you do once you reach 4x is less than or equal to 7? You see, I got to this stage, right? But what you really want to do is you want to get x by itself. And what we're doing here is we get a 4x. And 4x is basically 4 times x, right? And what is the opposite of multiplication? It's division, right? That's why we divide by by 4, not negative 4. By 4 to cancel it out. But we get x by itself, but this is an inequality. So to keep the things the same as it was in the start, so you have to do it to both sides. Okay. So you divide both sides by 4. The 4 here cancels out. And then you get 7 over 4. Okay. You're asking me good questions. So now let's graph it. Okay. So x is less than or equal to 7 over 4. We have our number line over here. Our x-axis, 0 right here. Let's say we have our 7/4 right here. And then this is where x is going to be. And then right here, x is going to be less than or equal to 7/4. So everything to the left of the closed circle should be x. And why we have a closed circle, I talked about it before. If it is less than or equal to or greater than or equal to, then we have a closed circle. Now, if this was just a less than, we would have a open circle. Okay, next. Number 3, graph this inequality. This has 2 variables. And actually, I'm going to walk you through this one. And I made a mistake of putting an equal sign. Let's just say it is, okay. Let's say it is less than or equal to. Okay? Less than or equal to. Now, this is a slope-intercept form. Okay, this is slope-intercept form. Now, what is slope-intercept form? Slope-intercept form is y equals mx plus b, where m and b are integers. Okay, they're integers. And right now we have 2 integers in place of m and b. Now, what is b? B is our y-intercept, and m is our slope. Okay, so since we have 2 variables, we need the y-axis as well. Let me draw my coordinate graph. Now, so y is less than or equal to 3x minus 2, right? And b is negative 2. That's why we have our y-intercept right here. Y-intercepts are always going to be on the y-axis, so you can easily tell it's negative 2. And then we have our slope, which is 3 over 1, or negative 3 over negative 1. So we can just, slope is vertical change over horizontal change. So let's go up by 3 first, because since it's vertical change first, 1, 2, 3 right here. Okay. And then don't forget we have to go to the right by 1. This will be our x change in x. Okay, go to the right by 1. We get this point, and then we can also utilize this alternate slope. Okay, go down by 3. 1, 2, 3. Go to the left by 1. And this should form a straight line. Okay, my line isn't so straight, but if you use a ruler, you will find that this is a straight line. And that's about it, except that shade it in, because unlike an algebraic equation, it's not just a single Okay, it's not just a single solution. There's a bunch of solutions. If x is less than if x, let's say x is less than 3, there can be infinite possibilities. Infinite. There are even infinite decimals between 2 and 3. Okay, that's why there are infinite possibilities. We just have to shade that in. Okay. And also, just like when we are graphing this single variable inequality, this dot, has a big difference. And when we're graphing two variable inequalities, this line, it has a very these graphs, a lot of them are very different because of this line. Now why? If this were just a less than or a greater than sign, then we would have to make this a dashed line. But since it is less than or equal to, or a greater than or equal to, then we have to make this a solid line. So be careful when you're graphing. So that was quite a long review of basic inequalities. Now, I want you to learn about compound inequalities and absolute inequalities. So compound inequalities, they're pretty easy to get, and I want to get this pretty quick over with. I'm sure you guys can keep up. These are pretty easy. Once you know basic inequalities, you should be able to understand. But when I'm explaining absolute inequalities later on, there might be some problems in understanding, and that is where I'll probably spend most of my time. So, without further ado, let's go into compound inequalities. But first, remember I promised to check the chat regularly, so any questions? Okay, very good, Carney. Isn't it something like this or that? Or is it that for two sets of inequalities with the same variable? Okay, very good, Carney. You understand some many compound inequalities. But your definition is a bit off, so later on I'll polish that definition. So basically, a compound inequality is just an inequality that combines two simple inequalities. And now I'm going to give an example. So what is a simple inequality? Simple inequalities are kind of like this. X is less than okay, so x is less than 3, and let's say x is greater than negative 3. Those are simple inequalities. Of course, they can be a bit more complicated, like 2 minus x is greater than negative 3, something like that. Okay, something like that. It just can't be like really fancy, a bunch of fractions, a bunch of square roots. Those are still inequalities, but those will be harder compound inequalities. Okay, a lot of solving to do. But today we'll just be working with these very, very simple inequalities. I'm just introducing these compound inequalities to you, so there won't be a lot of complicated ones. Just simple inequalities. Now, why do we call it compound inequalities, right? I just wrote two simple inequalities. That's all, right? That's all. Now, you might think these are two. What you can actually do is you can combine them. X is greater than negative 3, right? X is in the middle. Okay, X is greater than negative 3. Yeah, let's flip that over. X to the right side. Okay, now X is less than 3. So we can do this, right? So negative 3 is less than X, and X is less than 3. Now the graph of this, as Carney gave us a diagram of, this would be 0. This would be negative 3, and this would be 3, right? And x, remember this is a this is a less than sign, no equal to, so this would be an open circle. X would have to be somewhere around here, right? It's sandwiched between -3 and 3, right? So as Carney like Carney's diagram over here, it's very like the first plot, right? Very like the first graph. Okay, very good. Okay, so but sometimes when you solve an inequality, okay, so I'll teach you how to do this later. So how to solve? Okay, let's see. So if we're going to solve this, okay, there's some background noise, so let me quickly mute everyone real quick. Here we go. Okay, so how to solve these ones? So negative, let's say -3 is less than 5 minus x, which is and 5 minus x is less than 9. Okay, so how are we going to do this? Okay, so actually let me change this up. This might be a bit confusing at first, but this should be quite easy enough. So with this, we can this compound inequality basically just is made up of two simple inequalities, right? So how to solve this one? We want to find out. We have to simplify this, right? So we can turn this into two inequalities. So on our left-hand side, we have -3 is less than x plus 5. On our right-hand side, we have x plus 5 is less than 9. And we can individually solve these, right? Right here, we can have, just move the 5 over here, right here, same thing, okay? So -8 is less than x. And x is less than 4, okay? And you realize that we can combine them again, right? Combine them into what? Negative 8 less than x, and x is less than 4. We can combine them into this solution. So that is how you solve a very basic compound inequality. It's quite simple, right? Quite simple. So any questions about? Okay. So no questions? Okay, Reza, is it -4 is less than 2x? -4 is less than 2x. Okay, what do you mean by that? -4 is less than 2x. Okay, this is a compound inequality. So you're probably just not going to have one solution. Either two of these solutions put together, or sometimes, okay. Huh, okay, I get it. So sometimes, okay, okay. So sometimes you can't combine them. In this example, I combined these two individual solutions to these two inequalities, right? And sometimes, let's say we get the solution x is less than 4 and x is or okay, or x is less than something else, okay? So later on, you'll see what I mean. You can't sometimes the signs don't match up and you're going to have to you can't combine them. It doesn't make sense if you combine them. So you just have to do -8 is less than x or x is less than 4. But in this case, we can combine them. So to clear up your understanding of this, let's try to do a very simple problem. Okay, let's do a simple problem. And of course, please keep in mind that if you divide by negative in a compound inequality, you also have to change the signs. You have to change both of them, in fact. So please keep that in mind. If you come across, if you divide by negative, you're going to have to change the signs. Uh, it's also an inequality, compound inequalities. So remember that concept or rule. Okay. So this is our first problem. 3 is less than x minus 4 is less than 8. Okay. I'll give you a few moments to solve this one. Okay. Frank says 7 is less than x is less than 12. Very good. Very fast answer. Okay. Any more answers? Okay, Jason says the same thing. So Carney says the same thing. So a lot of you get it, and I'll walk you through it for those who haven't gotten an answer. Now this one is why I call it simple. This one you don't actually have to put it into equations, into two separate equations. Okay, so but let's just do it. Let's just put it into two equations, and let's see. Okay, let's see what we can combine it into. And let's just solve all of them. Okay, so 7 is less than x, and x is less than 12. And those, we can combine those, right? 7 is less than x is less than 12. So you are all correct. But the problem is, let's say you were in a competition, and as I've been to a lot of math competitions before, and I know that a lot of them they need you to be very fast. So even if you get it correct, okay, there's points for getting it correct and there's points for getting it fast. Okay, so you have to get both of them. You have to get it correct and you have to get it fast. And there are two methods to solve this problem. Okay, two main methods. And the first one was what I showed you. Okay, putting it uh into separate equations and then combining them. Okay, but the most fastest, okay, the fastest way would just to do this. Just from the middle, go to the both sides. Okay, from the middle, x minus 4, add 4 to 8 to the right hand side, and add 4 to the left hand side. Then we can get it very easily, right? So that is the fastest method. So if you see anything like this, then that is your cue to use this method. It's very fast. Okay, much faster than the others. Okay, and you can also do it in this previous problem, right? In this previous problem. Okay? So when you're solving these compound inequalities, please make sure, please take note of the problem, what it's asking you. Look at the problem intently, and you can figure out which method is the fastest, and that will help you a lot during whatever math competitions, or it's just more efficient. Okay, so does everybody get the problem? Everybody get it? Okay. Math counts. Math kangaroo. Yeah. Yes. Math counts. Math kangaroo. I know all of them. Okay. Those are very, very popular math competitions, and uh there are a lot of others as well. So next problem. Number 2, solve this compound inequality. 4 is less than 3 minus 2x is less than 7. Okay? This might, there might be some mistakes in this one, and I'm not going to tell you specifically why, but it involves a very special rule in inequalities. That's all I'm going to give you, and that is a pretty helpful hint. So please keep in mind that hint that I give you. So look at this problem and try to solve it, okay? But make sure to check your answer. There might be some tricks in there. Okay. Art of problem solving. No, I've not heard of that. But I've heard of the art of war. Okay. So please solve this problem now. So, are there any of okay, Jason, the art of war, not the arc of war. The art of war. That's a very famous ancient Chinese book, I think. Art of war. Okay, I think it says something about war strategies and something like that. Okay, so Frank says negative 0.5 is greater than x, or negative 1/2 is uh greater than x, but please keep in mind that there should be two solutions. Okay, there should be two solutions. So, and you can probably combine them later. So if there are no answers, Frank and Jason, very good for and Frank, uh, says okay, negative 0.5 is greater than x and less than negative. Okay. So how is so this is a problem, okay, Frank? This is a problem. Now x cannot be less than negative 0.5, and uh less than -2 in this compound equation. Okay, so either you write those two equations separately. Okay, you cannot combine them. So let's solve this anyways. So 4. Okay, so for this one, let's just practice. Let's just put them into two equations first. So 4 is less than 3 minus 2x, and 3 minus 2x is less than 7. Okay, very good. Move the 3 and move the 3. Okay, 1 is less than -2x. -2x is less than 4. Very good. And -1/2 is greater than x. Why? Because you divide by a negative. So divide by a negative, change the sign. Okay, and you also divide by a negative here. X is greater than -2, right? And what is this? You can combine them, right? So negative 1/2 is greater than x, and while -2 is less than x. And let's turn it into this. -2 is less than x, but x is less than -1/2, right? Okay, you can change it like that and switch it up. Okay, but remember to change the signs when you're switching it out. Okay, Frank and Jason, think you made a mistake. You forgot to change the sign right here, didn't you? Forgot to change the sign. So as I said, that was regarding a very big rule of inequalities. So please pay attention to that. But overall, very good. Okay, you solved a portion of it. So very good, very good. And now let's go over absolute value inequalities. Okay, a definition. Okay, the definition of an absolute value inequality is just an absolute value inequality is an inequality that has an absolute value sign with a variable inside. Okay, very easy, very simple definition, and you can tell from the title, absolute value inequalities. You can tell what it is. Okay, so on the next slide, I will start teaching you how to solve absolute value inequalities. But are there any questions on this last compound inequality problem so far? Okay, no questions. And Jason, the 7 military classics of ancient China. Okay, never heard of them, but not too into military strategy books. But okay. So, Carney, yes, absolute sign. Okay, so I'm going to teach you how to solve this one. And why this is so confusing is, and I'm going to teach you why it's so confusing. So, yes. Okay, so basically an absolute value inequality is just an inequality that has an absolute sign with a variable inside. But it just doesn't have to be only a variable inside. It can be 3 minus 2x is less than 12. Okay? It can be that. It just has to have a variable inside. Okay? There can be also numerals inside as well. Okay? So how to solve this one? And you know absolute value, right? In a few grades back, you can probably remember your teacher taught you absolute value, but I'll go over absolute value. Absolute value is basically, okay, absolute value, for those who don't know, write this down. Okay, absolute value is the distance. Okay, distance from 0. Okay, the distance from 0. So what is the absolute value of 12? So what is, okay, let me draw a number line here. 0, this is 12. So what is the distance between 0 and 12? That would be the absolute value. That'd just be 12, right? But what is the absolute value of negative 12? That will still be 12, right? So you just get rid of the negative. There are no negatives in absolute value. Therefore, if the absolute value of x is less than negative 12 or 0, then there is no solution. Okay? If the absolute value of x is less than negative or 0, then there is no solution. And this applies for less than or equal to as well. You can come up with the biggest number you can think of. In this case, it'd be infinity, negative infinity. Okay, the very bad infinity sign. Okay, negative infinity. The absolute value of that would just be infinity, right? Then that cannot be lower than negative. Okay, so if it's less than or equal to negative or 0, then there is no solution. So keep that in mind. Okay, so let's solve this one. So the absolute value of x has to be less than 12, right? So let's try to understand what that means. Okay, what does that mean? So the absolute value is basically the distance from 0, right? And the absolute value of this has to be less than 12. It cannot. Can x be negative 11? What is the absolute value of negative 11? It is just 11, right? Is that less than 12? Yes, that would suffice. Can 11 be x? Yes, as well, because its absolute value is 11, which is less than 12. So we come up with this. We have negative 12 here, and we have 12 here. X can be anything. Can be anything in between these two numbers. And there are infinite possibilities. Okay? Be anything between these two numbers. Negative 12 and 12. Okay? So does everybody understand this absolute value? Okay, yes. So let's go through some practice problems. Uh, so without further ado, let's do this problem. Solve this absolute value inequality. The absolute value of 7x is greater than or equal to 21. Okay, so please solve this one. Okay, negative 3 to 3. Okay, Very nice. So as I said here, this solution would be I forgot to write it. Be this, right? Okay, this would be the solution. Now, okay. So this problem. First, let's define the meaning of what is the absolute value of 7x. Has to be greater than 21. Okay. So the absolute value of 7x. Okay. Our number line right here, and this would be 0. This is 21. This is negative 21. 7x has to be greater than the absolute value, greater than or equal to 21. Now, it has to be greater than. It can be less than, right? If it goes this way, then it's less than. That is why our line has to be this way and this way. Okay? They never meet. That's why our lines have to go that way and this way. Okay? Let's say negative 22 would be here. Negative 22. What is the absolute value of negative 22? It'd just be 22, right? And that is greater than 21. That meets the requirements. Okay? And let's say 23. Okay. Accidentally erased that. So 23 would be here. What is the absolute value? It is 23. Is that greater than 21? Yes, it is. So now that we know, okay, right now we can't come up with a compound inequality because it is either x is either less than negative 21 or greater than 21. 7x is less than negative 21, okay? Or greater than 21, okay? So those are our solutions so far, and we can solve them. Okay, let's solve. Divide by 7 and divide by 7. That's all. Okay, so x right here be less than negative 3. X right here would be greater than 3. Okay, so what is this? X, okay, is greater than 3, right? X is greater than 3. Okay, and x has to be less than negative 3. Okay, less than negative 3. Oh, so there we have it. 3 is less than negative. Yes, very, very true. Of course, this is not true. Now, why did I say you can't combine these? Because they don't make sense, right? When I explain compound inequalities, you can't combine these, right? It wouldn't make sense because 1 is negative, 1 is positive. So you can't combine these ones. Okay, 3 is definitely not less than negative 3. Okay? So when you're doing these problems, please pay attention to your answer. Make sure it makes sense, actually. So this would be x is less than negative 3 or x is greater than negative 3. So you see this or a lot in absolute value inequalities because sometimes they're just like this. Okay? Or. Okay? And usually, and probably always, I haven't confirmed yet, but from from all the problems I've solved, I've concluded that if this is a greater sign, if x is greater than something, then it'll probably end up in this. Okay? The arrows will go in opposite ways. So that's probably why if it's going to be greater, then it's going to probably be or, something like that. Okay. Now, any question on why you can't combine? Uh, so a lot of you combined it, and that doesn't make sense, right? -3 cannot be greater than 3. So, any questions so far? Now, if no questions, then I will continue. Okay. So our last problem, we don't just have a variable here. We have a whole algebraic expression, 5x plus 3. Absolute value of 5x plus 3 is less than 7. So please solve this. Please try to solve this and put your answer in the chat box. I'll give you a few moments. Okay. So no answers yet. Then I'll walk you through this one. This one is more complicated than the last one. So what is the meaning of the absolute value of 5x plus 3 is less than 7? Okay. So this value, the absolute value of 5x plus 3, okay, has to be between 7 and -7, right? That is what 5x plus 3 would be. Now that we've figured out that the range of this thing, then we can simplify these equations. So we can conclude that 5x plus 3 will be greater than -7, but less than actually let's write it like this. Okay, -7 is less than 5x plus 3, and then 5x plus 3 is less than 7. Okay, now let's simplify. Okay, move the 3 and move the 3. You get -10 is less than 5x. 5x is less than 4. Okay, we divide by 5 on both sides. Okay, so we get x is greater than -2. Right, and then we get x is less than 4/5. Right, and now we can combine it. -2 is less than x, which is less than 4/5. That is our answer right here. Okay, so does everybody understand this answer? Are there any questions? Okay, yes, very good, very good. So you guys were very good today, very active in participating and answering questions. And that will be the end of my class. So thank you for listening, everybody. And I hope to see you next class. And maybe next class I'll introduce algebraic functions, and then we'll learn domain and range and interval notation, that kind of stuff. So goodbye, everyone. And are there any questions? If there are, please stay back and you can ask them.